4.3, dividing polynomials. Everybody ready? Okay, there's going to be two types of problems today. This kind of goes back more so to 4.1 than it is 4.2. Okay, there's going to be two types today. The first type is when you have a, what's called a polynomial, right? Multiple terms like that, divided by a monomial, one term. So you have two types, okay? Polynomial, whatever, divided by monomial, okay? And it's what you're dividing by that's going to be the difference, okay? This one's you're dividing by a monomial. When you're dividing by a monomial, all right, it's important to notice the difference. This one like this, all you do is split this off into three separate problems, okay? 6, x to the fourth, y to the third, divided by 3xy. Plus 12 x to the third y squared divided by 3xy minus 18 x squared y divided by 3xy. Right, because that 3xy is like a common denominator. See that? It's common to all three of these terms up here. So you split it off into all three. And then you simplify each individual fraction like we did in 4.1. So 6 over 3 reduces to what? 2. X to the fourth over x is x to the third. Y cubed or y cubed over y is y squared. I don't know why I'm like underneath the first one. Move this, make it look a little better. There we go. Alright, plus 12 over 3 gives you 4. X cubed over x gives you x squared. Y squared over y gives you y. And then a minus. 18 over 3 gives you 6. X squared over x gives you x. And y over y gives you 1. So no y's. That's your answer. If there were like terms in there, you would combine those, but that'll be very, 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 very rare. Okay. Now they can give these to you in a few different ways. Okay, this one's one of them. They can give it to you where you're dividing, like with the old school division sign. All you got to do to fix that is literally just take it. Well, here, I'll even do it like this. Take and put 8 CDF underneath each term. Alright, it's no different than the last one you just did. And then you just simplify those three. So we're done with this now. Simplify those three. Now sometimes you'll have fractions, okay, and that's alright. That's no big deal. You're dealing with fractions with these chapters, or with this chapter, these lessons in particular. So you'll have to reduce some of these. So 20 and 8 reduced by 4, so that's 5 over 2. And then take away an exponent from each C, D, and F. So C4 goes to 3, D squared goes to D, F's cancel out. Then you go minus 8 over 16 goes to 2. Same way, C's cancel, D's cancel, F you're left with 1. Plus 4 over 8 is 1/2, and then C, D, F all cancel. So that's your answer. Now, this notation I think is probably the most confusing. Okay? And here's basically what I want you to do with it. You see how the 3x, see how it's a multiplication, right? You're multiplying by these, but you see how this is to the negative first power? All that means, same thing. It's still dividing. Alright, now you'll see this notation in your book, okay, on the homework. So that's the only place you'll really see it. You won't see it on quiz or test, so I'm showing it to you guys just so you know how to handle it in your book. You just divide it again. Alright, that's all you got to do. So you take out that 3xy there and divide each one of these by 3xy. Okay? That's all you got to fix. Take out that 3xy to negative first, put it underneath each term of the other one, and then simplify again. So 18 over 3 gives you 6. X squared over x gives you x. The y's cancel. Plus 27 over 3 gives you 9. X goes to square. Y squared goes to y. And then z tags along. Type 2. Okay. Type 2 is when you divide a polynomial by a binomial. Okay? Now, if you go look in your book and write everything that's up there right now, write down. I'm going to do this one the way the book does it, and which is long division, but I don't want you guys to do it, okay? I just want you to watch something for a little bit. The way you're supposed, or one of the ways, the long way to do this is long division, okay? And I'm talking about long division like whenever you did back in the day, let's see, you know, like 30 divided by 2. You know, 2 goes into 3 how many times? 1. 1 times 2, 2. You subtract, you get 1. You bring down the 10. 2 goes into 10 5 times. 5 times 2 is 10. Subtract equals 0. There's your answer. Yay. Okay? That's what they're doing with these long division wise. Alright? Now, honestly, that doesn't really matter to us as far as long division goes. The only place that matters is at the end, which I'll show you then. Okay? There's a shortcut, and we're going to learn the shortcut. The shortcut's called synthetic division. Alright? Synthetic division. It's whenever you're going through and you're dividing polynomials by binomials. So as many terms as God wants you to have, and then 2 terms in your binomial. Okay? Now, there's a couple of things you need to make sure of with these. For you guys, the main one is number 1. You need to make sure that all powers are present. Okay? And what I mean by that is this. Whatever power your polynomial starts with, you need to make sure that all of your powers from that power down are present in your polynomial, including the x to the 0, which is called your constant. So you need to make sure, since this one starts at 3, you need to make sure you have 3, 2, 1, and 0. So 3, 2, 1, none. So we're good there on this one, okay? Everybody see that? The second thing you need to check, and this won't happen to you guys, but I left it up there just for funsies. Your coefficient of x in your binomial has to be 1. Okay, so this coefficient has to be 1. If it's not 1, you guys shouldn't be doing it, and I messed up. Okay? Because it gets a little more complicated. Alright? Here's how it works. It's a process. It's a new process. Okay? You want to take the coefficients of your polynomial. Okay, so the 2, the negative 13, the 26, and the negative 24. You want to write them on like one of your notebook lines. Okay, so 2, negative 13, 26, negative 24. Okay, rewrite them. Don't be lazy about it and try to do it with the polynomial. Okay, it gets messy. Rewrite it right. You can rewrite it right below it. That's fine, but rewrite them. Okay. Down just a little bit. Leave like a notebook line right here. Okay, leave a little space right there. And then draw basically like a big equal bar. All the way through. Alright. Good so far. Off to your left hand side, I'm going to draw like this little half box. Actually, that's the wrong color. Okay? In that little half box, you're going to put a number. The number you put, watch how I draw this, is that number's Opposite. See how I drew that? With sign included? Make sure you do that also, okay? So the opposite of negative 4 is positive 4. So the opposite of this will always go over here. Always remember that it's the opposite, okay? That's one of the major mistake makers. It's the opposite over here, okay? That's how you set these problems up. Any questions? Wonderful. Now, I'm about to show you the most important part to synthetic divisions. Ready? Put an arrow underneath your first one. That first number. Okay? Put that arrow there. Now, what do you think that arrow means? Slide the number down. Good. Slide the number down. Okay? Now, we're going to give this line here a name. Well, I don't know. Maybe we won't. Oops, wrong key. Now, let it go. Alright, so your first step is to put this arrow in and slide this number down. Now, you're like, well, I'll just not ride the arrow and I'll just bring the 2 down. You know what? You do that. I don't care. I don't need to see this arrow. But it's extremely helpful for these reasons. Ready? Once you bring the number down, this number and this number get multiplied. Okay? Whoops, that's a W. I don't know why I put a W. M-U-L-T. Mult. Okay. You multiply them. So 4 times 2? 8. Wonderful. That 8 goes underneath the negative 13 right there. Okay. These numbers you add up. So it's negative 13 plus 8. Negative 5. You bring that down. Now look what you did. You brought another number down below. So what are you going to do? Multiply again. Right. So negative 5 times 4 gives you negative 20. And then you put a number here, so that means you're going to do what? Add and get 6. And you're going to multiply again, and you're going to get 24. You're going to do that and add them up, and you're going to get 0. Okay? See that? Not quite. Remember, this is a shortcut. Okay, so we got a little work to do yet, but it's a big time-saving shortcut. Okay. Does that process make sense? Pretty easy. Okay. Here's the big thing to remember, and honestly, I swear it is this arrow. Okay, because people just, if they don't put this arrow, you know what happens? Either A, they forget to bring the 2 down, and they just multiply by 4, or when they do the 2 times 4, they put 8 here, add these together, get 10, and then do it again from there. Okay? You always start with bringing the first number straight down. That's always your starting place with this. So make sure you do that. Put that arrow there because then that blocks you from putting anything else underneath it. Okay, see what I'm saying? All right, now, that's not our answer yet because this is a shortcut. We still got a little work to do. All right? Now, here's the part where I said I was going to show you the part that the long stuff, okay? So, whenever, don't write this. The real way you do these problems, 2x to the third minus 13 x squared plus 26x minus 24 is by what's called long division of polynomials, okay? All the way through, and you divide x minus 4, okay? Bear with me here. And the way you do it is just like how you divide numbers with long division. But except this time, since this is a binomial, you only divide these parts. So you're going to go 2x cubed divided by x. So x cubed over x gives you x squared. So your first thing here would be 2x squared. All right? Makes sense? Your x exponent, and this is the only part I want to show you, your x exponent went down 1 because you're dividing 2x cubed by x. Right? 2x cubed over x is 2x squared. Make sense? So, since this is a shortcut for this, the answer we would get up here is the answer we would get down here. Now, the slick part is, these numbers that'll show up in front is 2, -5, and 6. You have to remember to start one exponent down from what you started with on your final answer. So we started with an x to the third. When we write our answer, you're going to start 2x squared. Just like we did up here. See that? The -5 comes next, and -5 is going to be with x plus 6. Anybody want to guess what 0 is? Nope. 0 is 0. I know that. It starts with an R. Remember, we're dividing. It's your remainder. Okay, good. It's your remainder. All right, so that'll come into play eventually, but not this one. Whoops. Okay.
So we go down an exponent on those.
You go down from here, right? You go to square, and then you so this one will be square, this one will be the first power, this will be no power, and then this is your remainder. Okay? Pretty good? Let's try another one. Okay? So go through, yeah. Go through, make sure you got your powers, whatever you start with. Okay? Now you can start with whatever. Okay? It's not like there's a set one that you have to start with. So this one starts with square. So we need to make sure we have everything from squares down. So we got squares, we got our ones, and we got our constant. Okay, so we're good to go. So rewrite your coefficients. 1, 3, -40. And then in your box we'll go what? 5. Bring down the 1, and then you're going to what? Multiply by 5 to give you 5. And then you add. So 5 plus 3 gives you 8. 8 times 5 gives you 40. 40 minus 40, 0. So another remainder of 0. I always box my remainder too. I didn't know the last time, but I do. So we start with an x squared, which means this will be a x plus 8. These coefficients, see how this is a 1, see how this is a 1, they should always be that way. Not necessarily a 1, but just whatever you start with. Okay. Those are your ones that you're going to fill in from these. So like 3 goes here, -40 goes there. And these are the ones you add up to get to the ones from here.
Well, the last one I had 8, -20, and 24 right there.
So your next one. Okay. Once again, check, make sure you get your powers. Okay, a squared, a, and constant, so you're good. Rewrite your coefficients. So 1, 7, -11. And in the box goes what? -3. Good. Good catch. Okay, bring the 1 down. 1 times -3. -3. 7 plus a -3 gives you what? 4. 4 times -3. -12. Okay, -12 minus 11 gives you -23. Oh, boy. What's new? Last number's not a 0. Now, does that mean we did something wrong? No, it just means you have a remainder, okay? So we got to handle that now, all right? It's a pretty easy handle. Ready? Here we go. So that's why I always box it, okay? Just so I keep it separate. So that last number, as long as you have everything set up right, that last number will always be your remainder. Okay, so you still write the first two out like you normally would. You started with a squared, which means this is going to be a, or 1a, a plus 4. Just as if this was 0. Okay, nothing changes to that aspect. All right. Now, I want you to think about this. I'm going to do 13 divided by 3 over here to the side. Okay, you don't have to, but just watch me. 13 divided by 3 is what? At least the first whole number that goes into it's what? Or 3 goes into 13 how many times? That's what I'm wanting to ask. 4. 4. See, this is why I don't teach elementary, because I don't know these things. I just, you know. 4 times 3 is what? 12. You subtract those, right, and you get 1. Now, 1 in this case would be your remainder. Now, in grade school, you learned a few different ways to write a remainder. Everybody's favorite, R1, right? Yeah, we're too old for that. How else could you write a remainder? Garcia, mixed number, okay. That's a good answer because the mixed number would also include the second part of the mixed number because it's a whole number and a fraction. That's what you want. Because you would write this as 4 and 1/3. Okay? Let's look at this guy real quick. Okay? In the context of the remainder, that number 1, right, is what you got, or what was left, right? I'm going to put Rima because I'm running out of room up there. And why is it 3? That's the number you divided by. Good. You put 1 on top because that's your remainder. You put 3 on bottom because that's what you were dividing by. Expand that to here now. Your sign that follows 4 is going to be minus because it's a minus 23. Your remainder was what? 1/3. No, up down here now. 23. Okay, that's going to go on top. Divided by what you were dividing by, which was what? Be careful. No.
Oh, wait. -3?
No.
Was it?
What are we dividing by? It's a little bit of a trick question. Remember what this process is. It starts with an S. It's a compound word. No. No. It's synthetic division. You're right. Okay, that's a terrible. That was terrible. Wow. Okay. It's a shortcut. Right? What are we dividing by?
A plus 3?
A plus 3. That's what you are dividing by. This is shortcut work. Okay? Always keep that in mind. You're dividing your problem by a plus 3. That's what needs to go down here. All right?
Oh, that's the answer?
That is the answer. Okay? Questions on that one? We got one more, I think. Okay. Everybody good? Okay. There's no third power. See that? So, here's the trick. The rule says we have to make sure it's present. But we can't just go putting in some random number x to the third. Because then we change the question, which changes the answer. Which when Mr. Mormon goes and grades it, means I'm going to get it wrong. So, we have to put in a number without putting in a number. You see the dilemma? We got to put in a number without putting in a number. So what number can we put in that doesn't actually put it in?
1.
Nope. That puts 1 in.
X to the third.
That's 1. 1x to the third.
Yeah.
0. 0. When you're missing a power, you need to put in a 0, x to the third. And it has to go in that same order, okay? You can't just put it in at the end or wherever you want it to go. It has to go where x to the third in line would be. These powers need to be in descending order, okay? Now, one that we're not going to talk about here, and it's not going to happen too often, if this 12 wasn't here, if this is just x to the fourth, third, second, first, and there was no number at the end, you would also need to put in a 0. Okay? So be aware of that. It won't happen a whole lot. But after that, your process stays the exact same. Alright, so in your box is going to go -2. We got 4 for fourth power. We got 0 for third power. 2 for your second power. -4 for your first power. And 12 for your constant. Arrow. Equal bar. Bring the 4 down. 4 times -2. -8. Add to 0. -8. -8 times -2. 16. 16 plus 2. 18. 18 times -2. -36. Which makes this -40. -40 times -2. 80 plus 12, 92. Your numbers can get big here. All right, they can. So don't. So that's and honestly, that's the hard part to these. Okay, the process is pretty easy. It's also pretty easy to make a mistake, and there's really no good way of checking your work. Okay, so while the process is fairly simple, I would say fairly simple, right? You're just adding and multiplying. That's all. It's very easy to make a boo-boo, a slight boo-boo, a little boo-boo, and that whole problem will go ba-boom. All right? So, like I said, make sure you understand the setup, make sure you understand the process, because one slight mistake. Okay? And then you write your answer just like you normally would. So see how there was no x cubed here in the original, but we're going to go from fourth power to third power still? That's why it's important to make sure you put in that 0. Okay, to make sure that power shows up down here, plus you don't have a number missing. Okay, without that 0, you would end up with a power missing in the remainder, and it'd be mad chaos. So you have 4 x to the third minus 8 x squared plus 18x minus 40 plus this time, since 92 is positive, see that? Didn't box it again. 92. What are we dividing by? X plus 2. Good. And that's your answer. Your homework's on page 247, 13 through 15, 20 through 25. You have a quiz on Tuesday over 4.2 and 4.3.